I'm sure everybody has gone through this. Everybody has seen this in your engineering, in your degree. You have come across it, right? So we'll make it short. We'll make it crisp. If you have any questions, stop and ask. So computer network, right? Basic question. What does it do? So it basically allows everything to get interconnected, right? You basically connect among each other, the employees, the systems, everything else like documents, email, messages, website, blah, 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 everything. Everything is interconnected. But how is it connected is what the question is. But what do you call everything connected to each other? It's called a computer network or a basic network, right? So how do you think when a network is set up, how do you think it's talking to each other? How do you know whether my computer, my machine can talk to your machine and then do the data transfer? How? That happens something called as topologies. How do I know I need to contact you to get this information? Is where the topology will come into the picture. Topology is an arrangement where it's a way the machines are designed to set up, and the information will flow from one machine to another machine, and then they'll be connected to each other or to the primary network, whatever that is. So we'll look at the different categories of topologies. So we have got the first mesh. Then we have got the star, the bus, and the ring. I know you might be thinking that, I have heard this, I have known this. Absolutely brilliant. But we'll go through this again. So what does the star topology do? So I think we should be talking about the burst topology first, right? So the burst topology is nothing but you have the primary network cable which runs through, and then every other workstation will try to tap onto that line and then connect it as if there is a bus. It's the bus is nothing but you see a bus, it runs through one single line, right? It doesn't go through its own wish and will. So if there is a road, it will go on that road only, like on the main part of it, and then whoever wants to connect and get on the bus will need to have a line or a by-lane to that bus stop or to that road where they can come back, connect to it, right? So imagine if there is a road, and then like this is me, this is Aditya, and this is Ravi, correct? And if the bus is going through this way, the bus will start here, he will come in, he will take up, it will go, and then he will reach the end. But if the road gets broken here, right, or the cable gets broken here, or the communication stops here, rest of the other stations will never be able to receive the communication, right? The bus topology, as per what's written in here, all devices share a single communication line. It means they have one single cable where they will be using it as a backbone to connect to the network. Nodes are connected to the bus cable by drop lines, which is called taps, or drop lines and taps. So they connect to this tap, and then they get the networking to them. And whenever they want to communicate, they use this channel to do it. But the problem is, if there is too much traffic on this one cable, like too many people, like, all these other machines are trying to communicate, there is a possibility that the data packets or the network packets will be getting dropped or will crash and then will drop. Or these packets or these stations will have to wait for their turn to even send their communication out to the other machine or to the other network or to the other person in another network. So that's the limitation, that there is only one channel to go in and come out, where if there is another bus standing already in there, you cannot have another bus come in. The one bus has to go off, or one user has to send out his communication or his package to go. Till then, the other person will wait for his communication or wait for his turn. When that return comes, he'll do it. If there is any other occur, he'll have to redo his whole communication. So it's a very basic and non-productive way of sending out communication. Okay. So let's look at advantages and disadvantages. Advantages: ease of installation, bus uses less cabling. But disadvantages: difficult to connect and fault isolation, difficult to add new devices. So what happens is, you might say that, why it's difficult to add a new device. So as a philosophy, as a tradition, or as the architect itself, every network cable will be able to support a length of, a network cable of length, example 5 meters, can only support these many devices. The more number of devices it adds, that less, or the bandwidth reduces for every other system or host which is joined that particular bus, correct? So thereby, it's not that an accurate system, or that's not an easy system to implement, but it's very difficult to even do a fault toleration, or even say that everybody gets consistent speed. Because if you need to find out where the actual communication broke, you'll have to come check every other machines connected on the bus topology or the bus line, and then figure out where the communication is or where the fault is. So bus topology was the very first one to actually get implemented, right? Then we look at ring topology. Each host connects to exactly two other machines, creating a circular network. So this machine, as you see in the diagram here, connects to other machine, which is connected to a repeater. So repeater is nothing but it repeats the same signal, so that that signal gets boosted, and then it goes to the other station or other repeater. It's more or like that big microphones or big speakers which we place it while the Ganesh festival is going on. The actual set-top box or actual audio, the tape recorder is in some corner, but you'll have so many speakers with so many repeaters around that even half a kilometer down the lane, you'll still get the audio signal, that loud and clear, which will be like playing whatever song it is. It means the repeaters is nothing but it repeats the signal, so that the other person or other station in the ring can actually get the communication. So the signal is passed along the ring in one direction from the device to device. It will do a clockwise or an anti-clockwise. It can, if this machine wants to communicate to the station who is on the right hand side, he will have to send the communication to the left hand side station. It will go all around the ring and then come back and talk to the station which is on the left hand side. He cannot just reverse the direction of the flow and send it to this guy. And that's the disadvantage. So ring is relatively easy to install and reconfigure. Ring is better at handling load. Central server is not required to manage this topology. That's an advantage. It's easy for us to understand why, because we don't need any centralized servers to send out the communication, but we need each other to understand and forward the communication. Disadvantage: data sent from one node another has to pass through all the intermediary nodes to pass on to to reach the end node. As I said, if I want to send out somebody communication to my right hand one node, I have to send it out to left hand so that it can pass on to everybody else and then reach out to the guy which is next right to me. The transmission speed drops, and the number with an increase in the number of nodes. That's obvious. That's obvious. The more you add nodes in between, the more repeaters you get. That the transmission speed decreases, because every system will work in their own frequency and will have to the repeaters will work on own frequency range and the throughput range. So thereby the drops might be erratic, and you'll have to have a decrease in your transmission speeds. So if a single failure of node in this can cause entire network to fail, that's obvious. So if I'm trying to send communication to my left-hand person to reach the communication to somebody else who's like 3 or 4 hops down the line, if my left-hand guy fails, nothing works, because even though everybody else is working, the ring means every communication has to pass through this one failed node to even reach the other nodes. It means if one fails, the entire network goes down, right? And that's, again, not an appropriate way for us to set up our network. Moving on, the mesh topology. Mesh is every other device is connected to every other device, right? It can be, I've got 5 machines in my network. Every machine is connected to each other. Every machine, like a point-to-point connection. They know what the IP is, how they communicate, and everything else. Um, the term dedicated means that link carriers traffic only between two devices to connect. Yeah, so it can only connect between the term dedicated means that the link carries traffic only between two devices it connects. So this either connection or this connection or this connection or this connection. So it has dedicated connection among only two at a time. So look at an advantage. It can handle heavy traffic as there are dedicated paths between any two network nodes. That's how we see there's a defined network path for connection between the host. Failure of single node doesn't affect the entire network to fail as the other alternate paths of the data transmission there. So I can still reach out to the other machine even though my network path, dedicated network path, fails between the other machine. Right. So that's how the advantages. It's clearly visible. The disadvantages. Disadvantages is a lot of cabling. I need to lay a lot of cabling to even connect everything, and they need to be in the close proximity of each other. Because since I need to connect each other machine, I need to route, I need to dedicate the routing tables, I need to write the routing tables, I need to ensure the routing tables up and running, I need to ensure that the paths are accurate, I need to know the IP addresses are not changing. It means there's a lot of cost incurred to just set up and maintain the mesh network. The administration of mesh network is difficult because you need to keep maintaining and updating the routes and then ensuring that one machine is connected to the other machine, which is almost all the time, right? So this is expensive. Then we have something called as the star topology. So the star topology is nothing but you have a hub, and then everybody else is connected to a hub, right? Earlier it was a hub, probably it can be a router now or a switch now. So the hub is nothing but it receives every communication, it directly broadcasts every communication to every other person. So the star topology, each device has a dedicated point of control, which is the hub, which is contact this person. Hey, I need to talk to this station B. How do I do it? So it says, okay, it takes the communication from station A. It says, who is station B here? It will send out a broadcast message to even station C, station D, station E as well. So everybody else in the same network will receive the communication, and then the station B will respond that, hey, you know what? I am station B. Please send the communication to me. And then the communication gets set up. Right? So that's how the star is. The disadvantages of star topology is less expensive, easy to install and configure. It's robust. The one big disadvantage of star topology is dependency of of the whole topology, a single point or a hub. If the hub fails, the entire network fails. Right? So it means we need to make sure that the hub is running all the time, every time, so that we are able to talk to other host in my own network. So it can be like your Wi-Fi router, right? If Wi-Fi router is more or less like your hub, like not a hub but looks like a hub. You connect to your hub, and hub takes you to the internet, or your router takes you to the internet. But it's a router which is much more advanced and then much more intelligent. Correct? So, but if your router fails, what will happen? Nothing will happen. Your phone will switch to 4G and still continue to communicate. But if you don't have 4G, you're not connected. That's how it's like, in a rough sense, that's how it is. Let's look at hybrid. So hybrid is nothing but it's combination of two different type of topologies. Right? For example, if an office in one department is a ring topology is used, another star topology can be used. Connecting these two topologies will be called a hybrid. Right? So I am seeing here in the image, I have got a bus and I've got a hub. So it means the bus topology is connected to a hub topology, and these two topologies are, when these two connect each other, it's called a hybrid network. Right? Okay, so that's fine. Then what happens is you have something called as a layered communication. Why do I call layer? because when you send communication from your machine or you're trying to contact the other machines in the other network, your information passes through different layers, like how we are trying to portray as a, excuse me, how we are trying to portray here in this example where for somebody sending out a post message, right? So the sender writes a letter, puts it in an envelope, drops in a mailbox. That's a very high level. Imagine you are trying to write an email. What you do? You open your Gmail. You say xyz.com. You type subject. You will put a severity. You will attach your documents, and then you send it. That's a UI you will face it. That's a very high layer. You're not worried about how it works in the backend, correct? Then what happens? The letter is actually carried out from the mailbox to the post office. So it means when you send your mailbox, from your mailbox, it goes to the Gmail server, your Gmail server, which actually handles all these emails and says that, okay, what do I need to do? Okay, when the moment the letter comes to the post box, what does the post box do or the post office do? It identifies what's the source address and what's the destination address. Okay, this particular address is in Assam, Meghalaya, Bangalore, Chennai, Hyderabad, whatever that is. So, and how do I identify which part of which city or Pune or Hyderabad? It looks at a pin code, correct? It looks at the pin code. So it says, okay, I need to send this particular letter to a person in Hyderabad, in particular Hyderabad, in high-tech city, to a person called XYZ, right? That's how it's done. The lane, everything is done. The landmark is done. Now the letter is delivered to the carrier by the post office. So what it does, it identifies and sends it to the correct route. Like, okay, you need to go to this particular route, which will take you to that particular mail server. In this example, it will say that, okay, you need to go to Hyderabad. So you need to take this particular bus, this particular faster route or a flight, where this letter will end up at Hyderabad. So when the letter, so that's a route, that's actual, the pink line is nothing but the actual route which you're using to send the carrier, is the carrier. So now the parcel services or the flight or the post office will take this and put it in the bus, sends it, it takes the road, understanding that, oh, I have to go to Hyderabad, it will come in and ends up at the receiving post office, right? The Hyderabad's primary post office, which is the GPO, General Post Office. It receives it, central hub. It says, okay, I have received the letter in Hyderabad. Now what am I supposed to do? Where do I send this letter? It looks at the pin code and looks at the area. Okay, I need to send this pin code. So there is a box which says every letter to this pin code will have to put it in this. Same way, the letter will carry it, saying that, okay, for all these letters for this pin code, you as Kishore will carry out these letters and give it back. And it needs to go to that post office. It doesn't reach the user directly, but will reach the post office or the post box directly. So what happens? There is a truck which comes and says that, okay, I'm going in this route. I'll drop and go to each post office on that route and drop the letters. So it goes to high-tech city. From high-tech city, it says that, oh, I'm going to, from Secunderabad, I'm going to Paradise, Begumpet, Panjagutta. I'll drop every other, go to every other post office, drop the files and reach high-tech city and drop the letter at the high-tech city post office. Then what happens? The guy actually picks up the letter and travels to your area and then delivers the letter to you. Thereby, in a nutshell, you have seen that what happened there, how many people got involved. It means there is a route. The person who actually carries the letter from point A to point B, then from from your mailbox to the local post office, from the local post office to central post office, from central post office to a bus which takes you to the other destination, and from there on it does the reverse of it, what happens in the initial path. Similarly, when you send out a communication, you're like, if you're typing google.com, exact same thing happens, but which is called as OSI layer. The OSI layer is nothing but a mechanism, a protocol, a framework where your communication is broken into multiple sections, where each layer will handle different components of your data. And as it progresses through different layers, the data will get added. It will go through the internet cable, reach the destination, and it will go the reverse direction of unfolding or breaking apart and actually showing you the data. Ashish, you have a question?
No,
Ashish, you have a question?
no, sir.
Okay, can you mute, please? Yeah, thank you. So that's how it happens. So let's look at the layers. So we have got 7 layers in the entire OSI, platform as such. So first is the application layer, or the first is the physical layer. Physical is nothing but you see a network cable, you see a Wi-Fi, that's all physical. Then you have got a data link layer, network, transport, session, presentation, application layer. So these layers are nothing but the compare this as to example of a postman, right? So application layer in a very nutshell, application layer is what you're looking at the current, how do I say, the Zoom meeting right now. This is an application layer. Then the presentation layer in the backend will help you present the data to the application layer. The session layer is nothing but which is what is maintaining the communication between you and me, so that I talk and you can listen and see the presentation in real time, right? Transportation nothing but keeping the connection alive. How do I keep it? How do I provide session, transportation guarantee that, do I use TCP, session oriented, non-session oriented, all this TC transport is what it looks like. The network is nothing but how faster can I route the packets from one point A to point B, so that all this happens in real time. And the data link layer is nothing but all the communication which is going from your machine before it reaches the router or your physical medium. The data link layer will take care of it. And the physical switches, optic fiber, network cable, router switches, all the things are called physical, which is the actual medium where the data gets transmitted back and forth. Even though your satellite will also come into the physical. You might say that, hey, you know what? At the end of the thing, how my communication is going from one place to point A to point B, US to America, or US to India, probably, yeah, it's via going a satellite link or by going through an undersea cable, which is spread across, continents to continents. Again, that's also physical, right? So your OSI model was the very first framework which allowed everyone to understand and work around how do I create and how do I make sophisticated networks and make faster network communication.